Good afternoon, viewers. Now we have discussed, earlier we have discussed the layout of thermal power station. The layout, you can see in the layout coal. What is coal? The coal is required for the coal plant is situated at about 1 to 1.5 kilometer away from the boiler. So how to transport this coal? Coal will be received in the coal yard in boulders. So these boulders received from the coal mines through the railway wagons. These railway wagons will unload the coal at the coal handling plant. So this will be transported to the coal bunkers. So while transporting to the coal bunkers, these will be transported from coal handling plant, which is shown in the figure as a block, to the coal bunkers. From the bunkers, it will be slowly admitted into the mills. What is mill? Coal mill. Coal mill will make the 25 size of the coal into the powder form by ignition and supply of air. So these in the mill, in the coal mill, there will be boulders crushing the coal into the powder form. This powder form of coal will be transported to the boiler wherein it is ignited. How to ignite? We can ignite the boiler with the help of the igniter. Okay, the igniters will ignite the coal wherein supply of air is supplied by the FD fan, forced draft fan from the atmosphere. So combustion of coal take place. When the combustion of coal take place, a fireball is formed in the middle of the boiler. You can see the boiler. This will be a very high structure, about 70 meters height. Boiler will be there, wherein in the sides you will find the water wall tubes, in which water will be circulating. So when the fireball is formed in the middle of the boiler, the fire is transported to the water which is flowing in the water wall tubes, turns into the steam, latent steam, boiling steam, latent heat, latent steam, and then saturated steam and supersaturated steam. This is the combination of coal plant and the boiler. When the boiler combustion takes place, about 30% of the ash is waste. So this ash to be collected in the bottom of the boiler and sent to the ash plant, which is not shown in the figure, but it will be sent to the ash plant through the ash in the form of ash slurry. Ash slurry means ash plus water is mixed, and in the ash handling plant, ash pumps will be there, and this will be transported to the ash pond, which is about 3 to 4 kilometers away from the boiler and plant. So this ash pond can accommodate the ash slurry for 25 years. Okay, such a big ash slurry is transported daily and collected in the ash pond. The pond is of the huge structure, a valley-like thing, and this ash slurry will be stayed there. So you please think that how much coal is required. The coal required is for a 250 megawatt boiler 100 tons per hour or 2500 tons per 24 hours. That means if the two units are there, 5000 metric tons of coal is required to operate the two boilers of 250 megawatts power, which can generate 250 megawatts of power. So, such a huge, gigantic state we can overcome by in the coal plant we can put 15 days storage. 15 days storage means 5000 per day into 15, 75,000 metric tons of coal is to be collected from the coal mines and stayed in the coal yard. Okay, now comes to the boiler. So when the ash goes there, coal in, ash out. So boiler, you will find the combustion take place, and when the steam is formed, the steam is transported to the steam lines, where these main steam lines will go to the turbine through a valve. The main steam line is of the quality 540 degrees centigrade and 145 kg per centimeter square pressure. Such a steam will rotate the turbine, HP turbine and IP turbine, LP turbine. In the turbine, there will be three portions, HP turbine, IP turbine and LP turbine. The same shaft is connected to the generator also. Generator means here alternator. That same stuff. So when the steam is admitted at this temperature and pressure in the HP turbine, with this force, the blades of the steam turbine will rotate in the anti-clockwise direction and this shaft will rotate. So the same shaft is connected to the generator and the generator also rotates. When the steam admission is completed, the steam loses its energy and it is again sent back to the boiler to gain the temperature. It comes down to 320 degrees and it again went to the boiler area wherein this will be gained 545 degrees again and roll the IP turbine. So from the IP turbine it goes to the LP turbine. So 700 tons of steam per hour is generated in the boiler and same is transported to the turbine. When the steam dumped from LP turbine to condenser, the steam will at the pressure of 1 kg and temperature of 140 degrees is dumped into the LP turbine wherein 13,000 water tubes will be arranged in this Through these water tubes, the cooling water is sent, and when the steam is dumping in the vertically down, and the water will be circulating horizontally in the pipes, the steam gets turned into the condensate. This condensate will have 40 degrees centigrade and only 1 kg temperature, kg per centimeter square pressure. This will be collected in the hot well and pumped back to the boiler through LP heaters and HP heaters to the boiler. Originally, boiler feed pump will produce water, will send the water to the boiler at the rate of 600 tons per hour. So this will accumulate to 700 tons per hour. So now you can note down the mixture of pulverized coal and air within the bracket. Usually preheated air is taken into the boiler and burnt in the combustion zone. On ignition of fuel, a large fireball is formed at the center of the boiler and a large amount of heat energy is radiated from it. And a large amount of heat energy is radiated from it. The heat energy is utilized to convert the water into steam at high temperature and pressure. Steel tubes run along the boiler walls in which water is converted into steam. The flue gases from boiler make their way through superheater, economizer, air preheater, and finally get exhausted into the atmosphere from the chimney. What is superheater? You keep the superheater as a heading and note down this point. Superheater tubes are hanged at the hottest part of the boiler. The saturated steam produced in the boiler tubes is superheated to about 540 degrees centigrade in the superheater. The superheated high pressure steam then fed to the steam turbine. Economizer. Keep the economizer as a heading and note down this. An economizer is essentially a feed water heater which heats the water before supplying to the boiler. Keep the air preheater heading. A primary air fan takes air from the atmosphere and it is then warmed in the air preheater. Air preheater, full stop. Preheated air is injected with coal in the boiler. Full stop. The advantage of preheating the air is that it improves the coal combustion. It improves the coal combustion. Now, note down about steam turbine. Steam turbine heading. High pressure superheated steam. High pressure superheated steam is fed to the steam turbine, which causes turbine blades to rotate. First up, energy in the steam is converted into mechanical energy in the steam turbine, which acts as a prime mover, to generate. Full stop. The pressure and temperature of the steam falls at lower value and expands volume as it passes through the turbine. The expanded low pressure steam is exhausted in the condenser. Now put the heading condenser. The exhausted steam is condensed in the condenser by means of cold water circulation. Here, the steam loses its pressure as well as temperature, and it is converted back into water. Full stop. Condensing is essential because compressing a fluid which in the gaseous state requires a huge amount of energy with respect to the energy required compressing liquid. Thus, the condensing increases efficiency of the cycle. Full stop. Alternator. The steam turbine is coupled to an alternator. Full stop. When the turbine rotates the alternator, electrical energy is generated. This generated electrical voltage is then stepped up with the help of a transformer. Please underline the transformer, and then transmitted where it is to be utilized. Full stop. Feed water pump. The condensed water is again fed to the boiler by a feed water pump. Some water may be lost during the cycle, which is suitably supplied from an external water source, that is DM plant. Full stop. This was the basic working principle of basic working principles of a thermal power station and its typical components. A practical thermal plant possesses a practical thermal plant possesses more complicated design and multiple stages of turbine such as high pressure turbine, intermediate pressure turbine, IPT, and low pressure turbine. Again, so this is the thermal power station history briefly, and we will discuss advantages and disadvantages in the next.